All right, ready? All right, number 10 says the mat around a picture shown measures X inches across. So here we've got a picture inside and then a mat added around it. We don't know how wide the mat is. That's our unknown X. We know that the whole thing together is 44 inches long and 34 inches wide. So that's what's given. It says which one of the following equations says that the area of the picture only, the inside part, is 900 square inches. So we want this stuff to be 900 square inches. So it is a rectangular picture, so the length times width, a rectangular formula, equals this area. Again, the area of a rectangle is length times width, so 900 is the area, should equal the length times the width of the picture. Well, we don't know it exactly, but we can set it up in an equation because we know the outer dimension was 44, and then we cut in X inches is here and also on the other side, so we come in 2 X's. 44, that would be 44 inches, subtract X, subtract X. So the length is 44 minus 2X. And then the same argument for the width, it was 34 inches for the outer dimension. You came in X and X to get on the actual picture itself. So the dimensions, this would be the length width. We could solve it then from there, but it did not ask us to, just to set up the equation. Okay, number 11, we have a box. It tells us that the volume of our box is 350. So the needed formula is volume of a box is the length times width times height. The 3 dimensions multiplied together equals the volume. In our problem, it tells us our volume is 350, so that's given for V. Then we have to represent L, W, and H. Actually, H is also given. H is 5 inches. You all might remember this problem. You did it with the ARMCO example many times in that one particular quiz, so it's similar to that, only not quite as bad. I feel like it's a little better here. Okay, so the length is 3 more than the width. So the width is the one referred to as the basic unknown. I'm going to leave that as a W, and then the length is that plus 3. So the length could be represented by the width plus 3, that's L. The width I called just itself width, and then the height was given as 5. If you remember on our ARMCO problem that I assigned, the first thing you could do is divide out this number on the end. The height actually divided well, so we just did that. So divide by 5. The reason that's allowed is these are multipliers, so you can cancel out things that are multiplied easier. So the 5s can be reduced. 5 into 350 reduces to 70. So that's what I recommend you do first, is just divide out any multipliers just to reduce it. Then I know we're used to seeing our multiplier in front, which you could switch it over there if you like, but the W is a multiplier by that parenthesis, so you need to distribute it. So we've got 70 equals W squared plus 3W. So it winds up being a quadratic equation. Quadratics we set equal to 0, get it in standard form, so the 70 crosses over. So standard form, this one will factor. You can always use your formula if you prefer. Let's see, plus 10 and minus 7 would give you a negative 70 on the end and a 3W when you FOIL in the middle. Then you set each factor equal to 0. That solves to be negative 10, positive 7. Since we're finding the width of a box, the negative number will not work for the width of a box. So 7 is the answer for how wide it is. And the question is find the width. You know, I told you to make that note. Always answer what the question was, because they could have asked me for the length here or the width. Both of those were unknowns we were trying to figure out. But the question is find the width, so the answer is the answer. It is 7. If you needed to know the length is W plus 10, which would be 10 for that. All right, questions on that? It's just, you tried, didn't you? It won't go. You want to give it a try? See.
Right where your right is hitting that board.
Is that right? I'll try to stay over here. I'll try to stay over here for you. If, uh-oh, is Brittany gonna? No, almost. Okay, I'll try to stay on this side. Oh, there we go.
Must have got it.
It's still pretty bright though. I don't know. We'll see. Let's see if that helps. All right, number 12. Two cars leave an intersection, one going north and the other heading east, which makes this right triangle. So you've got a car headed north and then a car headed east, forming a right triangle. So that's kind of what's going on here. You're going to get a Pythagorean Theorem problem. It says when the car that's going north had gone 9 miles, so this distance is 9, the car, let's see, the distance between the cars, which would be this distance between the cars, is 3 more than the east distance. East is totally unknown, that's our unknown x, and then the distance between them is that plus 3, the east distance plus 3 from the reading of that. And then it says how far had the eastbound car traveled. So the eastbound will be our x, we're actually just solving for regular x. So the Pythagorean theorem is a squared plus b squared equals c squared. It only applies to right triangles that the sides are the a and the b, and then the c is always the hypotenuse, the longer side. So we could say 9 squared plus what squared equals quantity x plus 3 squared. Then you want to FOIL this x plus 3 out, simplify it as much as possible. You can do that by the FOIL method or by the squaring pattern. You will have an x squared, a 6x, and plus 9 when you simplify that. It looks like it will be a quadratic equation. So, but when you bring your x squared across, the x squareds cancel each other out. Just a regular x squared on each side, so they cancel out. And so it actually winds up being linear instead. So then to solve for x, we bring the 9 over, which is 72 equals 6x. Divide out the 6, and that is 12. So x is 12, and again, I'm cautioning you about making sure you answer the question asked. It did ask for the east distance, that's my x, so this is the final answer, x is 12. But they could ask you, what is the distance between them? 12 plus 3 for 15, you know, so always make sure you're cautious about that. All right, how are we doing? Okay, number 13. Also know that all of these steps that I'm writing out here are also in your Blackboard shell. I don't know if you've had time to notice that or not, but there's a solution guide. So as we're writing this, know that all of this is also on Blackboard. It's good for you to write it as we go. It's good to get it in your mind better, but you do have that resource as well. So any we don't get to, do know that that solution guide is on your Blackboard shell, or in your Blackboard shell. All right, number 13, here's an equation with lots of fractions going on, and like I mentioned earlier, anytime you have fractions in an equation, step 1 is clear your fractions. So to clear this fraction is a little more involved because it's abstract, you got a lot of algebra, x's going on there. So to find the LCD, we need to have it factored, if anything is factorable, into its prime parts, which just so happen to be those two terms. So this factors like so. And then to find your LCD, it's one of each type of factor. So we've got an x plus 7 factor and an x minus 2, and then repeated here. So this is actually your LCD, one of each type of factor. Is this better? Is it showing? So then we're going to times each side by that LCD. And so what the beauty of this is, it will cancel out all of your fractions. If it's truly the least common denominator, that means when you multiply it diagonally will cancel out the factors that we use.
What does that say on the bottom?
This one?
No, right there.
That's x plus 7. X plus 7. So this is really considered to be over 1, and you are multiplying it. The LCD is being times into this all the way across on both sides to keep the balance. So when you multiply it, the first one, the x plus 7 part, canceled. I'm not going to show that cancel because I'm going to use it over here, but it is canceled on this first one. 5 times the x minus 2 then is brought down. No denominator now. It canceled out my denominator. When I times it by the second one, the x minus 2's are diagonal, so the x minus 2's cancel. You have a positive 11 times x plus 7. And then lastly, on the right side, I times it by that LCD as well, which just so happens to be exactly what you have in that denominator. So it cancels it totally out and just equals your 9. And then you want to distribute and solve that. Now the reason I do want to finish this one for you is because we're entering the section in chapter 1 where sometimes the answers don't work. So really that note of checking, following up, check your answers. There's quite a few types of problems where even if your algebra is super clean and perfect, that the answers just aren't usable. So fractions were one of those times. I don't think it is on this one. What is that? I can't subtract backwards. 58? 58. Then dividing out the 16. And then reduce that. Let's see, it'd be 29/8. Did we make it? 29/8 on that one. Negative 29/8, so that is answer B. Now, also notice answer D is no solution. Sometimes there is no solution if your answer were so that it could not be used back in the original problem. The things that would cause that on this problem is if it would have been x is 2, a 2 minus 2 is 0, denominator makes it undefined, so we can't have that, or a negative 7. So if this answer would have caused the denominators to equal 0, they have to be omitted. So that would be a no solution if your answers aren't usable. All right, questions on that?
Okay, can you hold on for 2 seconds?
I will hold on for 2 seconds, yes ma'am.